Hi, I'm Yuri from CodeVibers. In this project, we handle AI automation in-house, develop AI tools for businesses, and run an educational academy. Here, we focus on engineering solutions, not just news for the sake of news, that can be directly applied to real-world products. Today's topic is for developers and technical product owners, from prompt to production. We'll walk through what needs to be added to a successful prompt to transform it from a demo into a production-ready AI feature, something users can actually use. By the end of this episode, you'll have a concise readiness checklist, which inputs and outputs to document, which errors to collect, how to verify quality, what to log, where to place fallbacks, and which metrics to monitor before release. If this format is helpful, subscribe to the CodeVibers channel, like the video, and hit the subscribe button. The main trap in vibe coding: the prompt gives a beautiful answer once, making it seem like the product is almost ready. But production doesn't start with a beautiful answer. It starts with the question, what must the system accept as input? What must it return as output? Where is it allowed to stay silent? And who will catch the error before the user does? The first layer after the prompt is the contract. For the AI feature, you must explicitly define which fields are required, which formats are acceptable, which sources can be used, what JSON or text constitutes a valid output, and what to do if insufficient data is available. Without this, the prompt becomes invisible business logic that cannot be properly tested. The second layer is Evals. Not a single monolithic test, but a small set of cases that reflect the product's real-world risks. These should include normal queries, malicious inputs, incomplete context, ambiguous phrasing, expensive tool calls, and examples where the system should refuse to respond.
Number 3 is coverage. When you're using these large LLMs, the issue becomes that you can't really use that for 100% of your traffic anymore. So folks are just sampling 10% of the traffic. That's just not the way observability should work at all. Net-net, evals are absolutely broken.
The third layer is the taxonomy of errors. Before release, you need to agree on which errors actually exist. Incorrect format, hallucination, missing required field, overly expensive tool call, policy violation, low confidence. For each error type, you need a defined response path. Fix automatically, request human intervention, return a safe rejection, or roll back the action. Layer 4, the expert cycle. In practice, quality improves not because the prompt gets longer, but because subject matter experts review false positives, missed cases, and edge cases, then update the evaluation criteria accordingly. This is no longer prompt engineering, it's quality engineering around the model.
Or outputs are actually just going to be incorrect. That doesn't work for AI agents at scale at all. To bridge this last mile gap from 70% to 100% accuracy, what we've noticed is the secret resides in your use case and your data and your context. So how do you bake that in? Enter subject matter experts.
Layer 5, runtime guardrails. These must be separated. Input guardrail validates the request before it reaches the model. Output guardrail validates the model's response after generation. Tool guardrail restricts what actions the system is allowed to perform. Fallback determines the response when quality falls below a threshold, e.g. retry, switch to an alternative path, escalate to a human, or reject the request.
With this fine-tuned small language model as a judge, as well as the prompt that you previously created, you can put this in production, and now you have a high accuracy, low latency, very low cost alternative to that LLM as a judge for 100% observability of your traffic. But it's not over yet. When you put this as
Layer 6, observability and cost. Logs must include prompt version, model, parameters, retrieved context, tool calls, latency, cost, evaluation verdict, and final status. Otherwise, after a user complaint, you won't know whether the issue lies with the data, model, prompt, retrieval, tool permissions, or an external service. A minimal release gate looks like this. 1. The entry and exit contracts are defined. 2. The evaluation set contains at least 30 cases. 3. Failure modes and their handling pathways are known. 4. Input, output, and tool guardrails are in place. 5. Each invocation is traceable. 6. Cost limits and P95 latency thresholds are set. 7. A rollback mechanism or handoff to human review exists. If any one of these items is missing, it's not yet production ready. Main idea. A prompt may be good, but production requires a system around it. Take one of your AI features and fill out all 7 release gate checkpoints. If you'd like to explore AI development in this level of detail, head over to the CodeVibers YouTube channel, like the video, subscribe, and visit the Academy on our website.